Good morning, everyone. Thank you so much for joining us today here, June 28th, this last Friday of June. My name is Devin Murray. I am with the company Schmersal, of course. I am specifically within the Technicum Engineering Service Division. And again, I'm excited to have you here today on this last Friday of June. As you may already know, June is National Safety Month, right? This is an annual observance sponsored by National Safety Council that looks at the safety both in and outside of the workplace. This National Safer Workplace Day, right? This last Friday in June to end off the National Safety Month is a day sponsored by Schmersal, what focuses on the safety within the industrial environment. Okay, so I will, at the end of this presentation, go into some more information about what this day is, why it was created, what you can do to help acknowledge and promote National Safer Workplace Day. But before we do that, quick introduction to myself. If you don't know me already, again, Devin Murray, the manager for the Technicum Services Division of Schmersal. Been with the company going on 15 years now, I believe. Wow. A background is electrical engineering. Have my TV certification for functional safety of machinery. So again, we'll talk more about what this day is at the end of the presentation. I do ask if you can use the chat field to ask any questions, and if we have time at the end of the webinar, I can definitely answer those questions. If not, your email will be captured, and I can reply back to any questions via email at the end of the webinar today. All right. Um, there are also a couple of handouts that you can download in your dashboard. One being, more information about what National Safer Workplace Day is, and then a brochure of technical services. I have that handout in there because I do not talk about Schmersal and technical services in this webinar. That's not the main goal here today, right? What we want to discuss today. Right. Here's the agenda for this webinar. We're going to start off by obviously talking about the safety life cycle of a machine. All right, so we'll talk about what that is, what are the stages within the life cycle, and what we need to accomplish with each stage within this safety life cycle of a machine. Okay, that will lead us into a brief discussion on National Safer Workplace Day. Time permitting, we'll look at a couple of workplace stats, some data, which helps highlight the importance of both National Safety Month and National Safer Workplace Day. Okay, I'll end off with a quick message, and again, if there's any time and questions, I'll be able to answer those at the end of the presentation. Okay, so the life cycle or the safety life cycle of a machine. There are plenty of really good articles out there that kind of talk about the safety life cycle of a machine and try to help break down exactly what those stages are and what you need to do what you need to accomplish within those stages, but they don't really go into detail about where this comes from. So I want to take just a quick minute to try to bring some ideas together about the machine safety life cycle. The first thing is, what is it, right? What exactly are we looking at? What are we referring to when we talk about the machine safety life cycle, right? In a nutshell, a real brief description of it. It's the process in which certain safety aspects are applied to a safety instrumented system, or SIS, as defined within a lot of standards, from conception to decommissioning. All right, so from the conceptual stage, we are trying to design this machine all the way up to decommissioning, right? The machine as you reach this end of life, and that is the part of the life cycle. Now, as far as the safety aspect of it, when we look at a machine, whether it's a mill, a press, a CNC, whatever the case may be, we look at the safety functions of that machine. This is what we're going to highlight, right? What are the safety functions and what do we need to do at certain stages to either add, evaluate, validate these safety functions, right? So this is part of that idea of the machine's safety life cycle. Where does it come from, right? Where does this concept come from? And there are quite a few different safety standards that speak about a safety life cycle. And one of them, it would be IEC 61511. Okay. This is a functional safety standard, and as we see here, based off the Safety Instrumentation Systems, again SIS, and it's developed more so for the process industry sector, but this standard is derived from IEC 61508. Okay, so here I am throwing a couple of standards at you, and again, let me try to tie these together. 61508. This is the standard that defines functional safety. Okay, and there's been so many standards that derive from IEC 61508. For example, ISO 13849 looks at the functional safety of a machine, and we'll talk real briefly about that standard later as we look at the cycles of machine safety. But if we just for 1 second look at this IEC 61511, because we're trying to understand where this life cycle comes from, there is this section that's highlighted in IEC 61511, all right, which is here, right, 52613. In this section, it lists the stages and the safety life cycle at which the functional safety assessment activities are to be carried out. Okay, functional safety assessment activities for the safety life cycle. We can apply this to machine safety. And the good thing about a lot of these standards are that they do reference each other, mainly because they all derive from this functional safety standard of IEC 61508. Okay. Within this section, 52613, there is this figure 8, which shows the different stages where we need to apply these functional safety assessment activities. This is where we start to see these concepts, right, of the machine safety life cycle. What I want to do is give a highlighted view of what these stages are. All right, so this is where they kind of come from. Again, there's plenty of great articles out there to help try to understand what these stages are, but they don't really go into detail about where this is derived from. Okay, so the stages that are described within the machine safety life cycle would be the risk assessment. Okay, so we'll talk about what the risk assessment is, and when we talk about what the risk assessment is, it again it'll be a highlight of what it is. We do have webinars, full-hour webinars and trainings on this particular topic. As we see here, it's just one element of the life cycle. So we'll just give a high-level view of what the risk assessment is. Once that's done, the next stage would be the safety function requirement specifications, or SFRS. Okay, we'll see what that's about. After that would be the design and verification. Stage 4 would be the installation and validation. The last stage here would then be maintenance, monitoring, and re-evaluating. So when we look at this, again, this is the entire life cycle. So the risk assessment, this will be at the beginning part of it, doing that, the conceptual design. And we will look at this over and over again at certain milestones throughout the life cycle of the machine. Okay. And as we look at the risk assessment, we may find that, okay, we need to do some type of risk reduction measures. This then brings in the SFRS. All right. Then we look at the design and verification, so forth and so on. So let's start to look at some of these elements individually. All right. So the first thing is, what is a risk assessment? All right. That's the first stage of the life cycle here, the risk assessment. The risk assessment is a systematic approach or process to identify hazards and evaluate the risks associated with those hazards to determine necessary risk reduction measures. All right. There are plenty of standards to help us understand what a risk assessment is, give us some framework to help guide us through the risk assessment. I list here three such standards. So ISO 12100, ANSI B110, and CSA Z432-16. Now, for those global companies on the line, you may see that your organization may gravitate towards ISO 12100, perhaps. Um, what we see here on this table, it's a description or a description trying to highlight some of the similarities between these three standards. All right. If we look at the beginning part of ISO 100, ANSI B110, CSA Z432-16 from our friends up north in Canada, the first part is determine the limits of the machinery. Okay, now this is going to be setting the framework of the risk assessment. All right, who uses this machine? What are the different tasks associated with this machine? What are the different roles associated with the machine? Where is this machine going? All right. So we start to set the framework of the risk assessment. Okay. The next step would be to identify these hazards. And here we start to see a slight difference between the three standards, where ISO 1200 just focuses on the hazard identification, and ANSI and CSA talk about a task and hazard identification. The main reason here for the difference is that ISO 12100 is more for machine builders, where ANSI and CSA can be tied back to the end user as well. So we look at the end user's responsibilities. Yes, we are more responsible for the task, right? How are we using this machine? What are our our SOPs and JSAs, right? So how we use the machine so we can identify some hazards and risk associated with that. Okay, after that, we look at risk estimation. And again, here there's a slight difference where the ISO 12100 kind of breaks this into two stages for risk estimation and risk evaluation, where ANSI and CSA group this together in just one step, whether it's risk estimation or risk analysis. The goal behind either this last two steps for ISO 1200 or this last step for ANSI and CSA is we have to quantify this risk. Okay, we quantify the risk because then we have to ask ourselves, is this risk acceptable or not? All right, is this acceptable? So when we look at quantifying the risk, you can honestly utilize any method you want, right? The key thing is making sure that we quantify it, right? So we have a baseline to work from. The standards again will give some guidance on how to quantify this risk, and the two main parameters that they focus on will be the severity of harm and the probability of occurrence. All right. Again, we have full-blown webinars on this process and trainings as well for this process. Not going to spend too much time because we do have some other, of course, stages to focus on. But we see here a table 2 from ANSI B110, which helps us quantify a risk. Okay, so if we look at this table, we see, okay, what it would be the severity of harm, whether it's catastrophic, serious, moderate, minor, and then we look at, well, what's the probability of occurrence of that harm? Very likely, likely, unlikely, or remote. So, for example, if we say yes, this risk would be considered serious. Okay, it's a serious risk, and the probability of occurrence is likely. So this is likely to happen. That intersecting point between likely and serious is high. So we can quantify this and say we have a high hazard. Okay, and then the question would be, is this high hazard acceptable? Right? Probably not, right? But it all depends, of course. Again, you can use anything you want for estimating the risk, and we often show the HRN method. This is something that we use and is used commonly throughout the industry, right? But this hazard rating number, HRN, where we calculated a numerical value for the risk estimation. Okay, and here they use four parameters: the likelihood of occurrence, frequency of exposure, degree of possible harm, number of people. Okay, I have seen the same parameters for HRN used with different numerical values. Okay, again, you can honestly create your own. You can use an Excel file, right, and create your own numbers and define the parameters, differently. Whatever makes sense for your organization, the machines that you're using. Okay, but that's the main thing. We want to estimate it. This is the first part of the machine safety life cycle, this idea of the risk assessment. Let's look at the machine, let's identify the task, let's look at the hazards and the risk associated with this, let's estimate this risk. Stage two, right? This idea of the safety function requirement specifications, right? SFRS. Okay. Again, what is that? What are we looking at? All right. So when we look at the SFRSs, these are the specifications containing the functional safety requirements for the risk reduction measures. So stage one, you identify hazards and risks, right? You quantify them, and then we say, okay, do we need to do anything about it? And then stage two is, okay, well, if we do need to do something about it, let's design what we need to do. All right. So some of the things that will be part of the SFRS would be something like the safety matrix. Right. What safety functions are we adding, and what do we want those safety functions to do? Right. What's going to be the triggering event? Okay, so if it's an e-stop, all right, so we have an emergency condition with the e-stop. What do we want to shut down? Right, what's that process? We have a guard door interlock, right, or a light curtain. We interrupt the light curtain. What are we expecting to turn off? Right, what drives, what motors are we turning off? We create a safety matrix. Okay, we want to add guarding based off of our risk assessment. Perfect. Well, how high does this guard need to be? How far does this guard need to be in relation to the hazard? So we start to utilize some standards. Okay, if we look at presence sensing devices, light curtains and safety mats, two-hand controls, these need to be positioned at a certain minimum distance. And again, this is another whole other webinar that we've done before. Okay, but the fine details, right, of what we're trying to create to have this risk reduction measure in place, right? What standards are we trying to follow, right? What ANSI standards are we trying to apply here, right? What ISO standards are we going to use? Is there a type C standard, which is a machine specific standard that we're trying to adhere to, right? Is this a robotic cell? And we want to focus on ISO 10218 or ANSI RA 1506, right? So we want to highlight this. We want to detail and describe what our safety requirements are going to be for this SFRS. All right. When we're trying to have some risk reduction measures in place, right? We fall back to our hierarchy of control measures. And I'm sure many of you have seen something like this before in some form of safety training, right? So when we look at a hazard, we're trying to reduce the risks associated with the hazard. Again, trying to formulate this SFRS. We say, okay, well, can we eliminate this hazard, this potential source of harm? Like, can we get rid of it? Can we redesign this part of the machine to eliminate it? That's the first thing we want to try to implement. The next thing is, well, if we can't eliminate it, can we substitute it? Right? Can we implement a less dangerous hazard than what we just identified? And a lot of times I refer back to the example of using chemicals for a process, and we identify this very dangerous chemical. Can we substitute this dangerous chemical for something less harsh, right? Can we substitute this immediate danger? If we can't substitute, or we need to apply further control measures to reduce this hazard rating further, we then look at engineering controls. Right? Can we apply these hard guards? Can we apply some type of safety component within the industry? Right? Do we have to develop a safety function? Then it would be, all right, what about administrative controls? Right? Training, right? Restrictive access to these hazardous areas or to these hazardous pieces of machinery. And the last thing would be providing personal protective equipment, just some PPE. Okay. Typically, what you will see is a combination of these. All right. For an existing machine, again, we think about the full life cycle, right, of a piece of equipment. For a new machine that we're trying to design, we may have a higher chance to eliminate an identified hazard. For an existing machine that's been running for 5, 10, 30 years, right? We may not be able to eliminate the hazard. We may not even be able to substitute the hazard, but we should be able to maybe, right, try to implement some type of engineering controls. And a lot of times, again, you may see a combination. So, right, we're going to implement some safety interlocks on there. At the same time, we're going to implement some additional annual training. So that's going to be some administrative controls. And we evaluate the process, and you know what? Because of this process, we might need some cut-resistant gloves. So now we start to add in some additional PPE. So a lot of times, you may see a combination of these control measures. If we can get rid of the hazard that we've identified, that would be the most effective, right? And if we only rely on PPE, this would of course be the least effective. All right, it makes sense, right? If we think about that, and if we look a little further into, again, trying to reduce the hazard that we've identified, or reduce the risk that we've identified from this potential source of harm of the hazard, because like if we identify a crushing hazard, right, as shown here in this picture. Okay, fine. First thing is, can we design this hazard out? Right. So can we, in this instance, change the shape of this potential source of harm to eliminate this crushing hazard? Okay. Again, when we are doing the design, doing the conceptual stages, we may have a higher chance for this. Existing machines, maybe not so much. And honestly, even when we're doing the conceptual designs, we may not be able to design it out, but again, we may have a higher chance to do it at that point. If we can't design the hazard out, we say, okay, can we implement some engineering controls? So the hazard still there, still resides with the machine, but let's go ahead and, in this instance, add some hard guards. We want to prevent access to the hazardous point. The last thing would be, all right, let's add some signs. Let's warn of the hazard. Again, here you would see typically a combination of, engineering controls and some warnings. All right, you would see on a machine, it would say there's a crushing hazard, and it would also say, do not operate without guards in place. Yeah, adding a sign is a step that we can implement. But this does not mean that we can go right to adding a sign. All right, so we can't go through our assessment and say, okay, we have a hazard. This hazard is, rated as serious. Let's just add a sign. Right, that is not how it works. Right, we have to go through this process, see if we can design it out, see if we can add some engineering controls, and then finally see if we can add some signs. All right. Once we go through that process of trying to piece together what our SFRS is, right? This package. What are we adding to it? Then we say, okay, let's go ahead and do our design and verification. Let's go ahead and design what we are trying to implement. All right, so when we look at things that we are trying to design and verify here, if we are saying let's use hard guards, right? The idea of the fixed guards. And we say, okay, well, how high and how far does the guard need to be? We'll use standards like ISO 13857, right? Or some of our ANSI standards, ANSI 1119, to see how high the guard has to be in relation to the hazard, in relation to the distance of that hazard. And based off the openings of the guard, how close can we be to the hazard? Okay, we want to make sure that we can't put our finger or hand through through the opening and reach that hazard. And so again, there's going to be tables and charts within these standards that would help guide us on where to place these guards if we're going to use fixed guarding for our control measure. We also want to make sure that we use the right type of material if we're using hard guards. All right, is this guarding going around an application where there's going to be projectiles, right? Are we guarding a robot cell? Is this an area where there's heavy washdown, right? And that's going to use high temperature, high pressure, caustic chemicals. Can this hard guard withstand that environment? Right? Things we have to consider when we're doing our design. We want to make sure that, if we're going to use hard guards, we want to maybe give the operator and maintenance personnel the chance to actually view what's going on inside of the machine, right? If we restrict, access so they can't see inside the machine, and especially for some of these maintenance tasks, it's gonna heighten the chances of bypassing guards, right? And just because someone can't see inside the machine doesn't mean that it's okay to bypass a guard, but it just introduces that possibility, right? So if we want to allow visibility into the machine, let's provide some guarding that does provide that. All right. And even when you look at mesh, right? Mesh, there's holes in the guarding. One may think, okay, fine, you can see past the mesh. We bring up the example of the difference between using black mesh and yellow mesh, where yellow is often seen as the color for safety. But if you apply yellow mesh all around a machine, all over the plant floor, it's going to be real difficult to see past that yellow mesh into the machine because the light is reflected off the yellow mesh. Where if you use black mesh on fencing, you can easily see past that guarding to see what's going on inside the machine. Okay, something we probably don't even think about, right? But something to consider. Uh, the last few things here for the guarding, as we do our design and verification, stage number 3 here, we want to make sure that the guard is difficult to remove. Right, so the standards call out, using fasteners that require a special tool for removal, and we want to make sure that we're not interfering with the process too much, right? We want to make sure that people are safe, but at the same time, we want to make sure that people can do their job, right? We'll make sure that they remain efficient, right? And studies have shown that a properly implemented safety solution can, believe it or not, increase productivity. Okay, so we have to figure out what works best for this application, what works best for this machine. All right, if we are trying to design safety functions for access guards, Right? Anytime we have a guard that can move, we need to monitor this guard. Right? So we would apply some type of an interlock device, whether it's a limit switch, a key to interlock switch, a locking device, right? Depending on what the risk assessment dictates. If we say, okay, we're going to add on a safety device to monitor this guard door, we then have to determine, well, what type of safety circuit we need to design to. All right, this takes us to another realm of standards, such as ISO 13449. Okay, so again, we have another webinar on this topic. We won't go into too much detail of what a performance level consists of and how we do the calculations and all that. But if we add a safety function, such as an interlock, a light curtain, a safety mat, we need to determine what that performance level requirement is. All right. What do we need to design this safety circuit to? Performance levels A, B, C, D, or E. And in order to determine what safety function we need to design to, or what safety circuit we need to design to, we can look at these parameters S, F, and P: severity of injury, frequency of exposure, probability to avoid this hazard. Okay. Um, for an existing piece of machinery, if we want to examine where we are with our safety circuit, we may be focused on just the category, perhaps, right? If it's a single channel system, a dual channel system, monitoring, things of that nature, we're trying to implement a new safety function, a new machine. We can look at the performance levels and the safety integrity levels. Okay. Not to go too far off the topic for this stage 3, but again, what we're looking at for performance levels and still ratings is how reliable is this safety circuit. All right, so those are some of the parameters that are required for performance levels. All right, we look at the category, the diagnostic coverage, the mean time to dangerous failure. These make up a performance level. Okay, that's a whole nother training, a whole nother webinar. Okay, but this is part of the design, right? If you want to go ahead and add a safety function, it's not just going to Google, right, and buying an interlock device and slapping it on a machine. It's, well, no, let's look at the hazard that we've identified, the risk associated with that hazard, and let's design a safety circuit that's going to be reliable to protect us against the hazard. Okay, because if we have a hazard that we've identified, a risk for an amputation or death, we're going to want a safety circuit that's going to be resistant against a single fault, right? More than likely. And it depends on the risk assessment, the SF and P parameters, right? But when you look at the severity of injury of S2, we're going to want a safety circuit that has monitoring, right? So monitor for faults, and again, more likely, something that's going to be redundant, okay, resistant against a single fault. That's the concept behind the design portion of it. When you look at the verification side of it, it's all right. Well, based off our performance level for this example, let's do some calculations. All right, we'll do some calculations using Systema, for example, which is a free software that you can download to help do those calculations for a performance level. All right. So you've done your risk assessment. You've done your safety function requirement specifications, pretty much highlighting, what you want to do for your control measures. You do your designs, your safety circuit designs, your block diagrams, your bill of materials, and now you go through your installation and validation. Okay. As far as the installation goes, this needs to be planned out. Right? If we talk about an existing machine, well, we need to find out, well, when can we have downtime to actually implement a new safety function on this. If we are designing a new machine, right? Well, are we do we have the material right for the different parts of this the machine here? Are we going to use in-house personnel? Are we going to use a third-party contractor, consultant? If this is a new machine, the OEM, do they have the resources to implement the safety aspects of this equipment? Do they understand safety? Or do they need to also farm that out to a safety consultant? Part of this installation plan, right? Creating some milestones, right? So that we can track our achievements, have some progress evaluation points. Okay, make sure that we stay on track. All right, this is again a whole another section where we're trying to make sure that we stay on schedule as best as we can. And as we all know, when we start getting into designing, whether it's for an existing machine or a new machine, it can be hard to stay on target dates. All right, there's a lot of different moving elements, but we want to at least start off with a plan, a plan of attack. Okay, so we go through the installation phase, installation stage, and then it's validation. Right? So once we start to actually install and implement these safety functions, we then need to validate the safety functions. And we can look at the standard ISO 13849 to give us some guidance on how to validate a safety function. Okay. We see here that the bolded statement here, the validation shall demonstrate that the safety function meets the relevant requirements. All right. So what you design, we need to make sure that it meets the relevant requirements. Right? So the standard goes into validation principles and what you would need to do for testing for different types of faults. Right, going through your safety program, um, introducing faults to this system that the system's been designed to withstand. Right, so if you design and wire a two-channel system, you should be resistant against a single fault. All right, so part of validation is let's introduce a single fault to the system. Right, introduce a fault and let's prove it out essentially. All right, let's see if this system reacts the way it's supposed to. All right, that's part of the validation. And this then goes into more detail of those individual steps, what the validation plan or record should look like, what type of information should be a part of that. Um, it also calls out a very specific requirement that the person that does the design and the wiring should not be the one to validate the system. And it calls out in standard. And if we think about that, yeah, that makes a little bit of sense, right? If I designed the system and I wired it, and I might have my blinders on when I'm trying to actually validate the safety system. Okay, so that's called out specifically within ISO 13849-2. The last stage, stage 5 of this machine safety life cycle is maintenance, monitoring, re-evaluating. This would include certain, periodic tests for the safety functional requirement specifications, right? For example, again, you're using light curtains and safety bats, two-end controls. We really need to do an annual stop time analysis on this equipment, right? As we use equipment more and more, obviously there's going to be wear and tear. The machine may take longer and longer to come to a safe condition once you interrupt the light curtain. Because of that, we need to do a stop time analysis on the machines to see, okay, how long now does this machine take to reach a safe state? And over time, we may need to either add some additional methods to bring the machine to a safe stop quicker, or we may need to reposition this presence sensing device a little further away from the hazard based off a safe minimum distance calculation. Okay, this is part of the maintenance and monitoring, right? Um, Looking at again ISO 13849 is functional safety standard for machinery. We do the calculations to determine what the performance level is. We also do some calculations to determine when is the high chance of us to experience a dangerous failure with this component, with this safety function. And based off of those calculations, we can put inside of our preventative maintenance schedule that we need to replace this particular limit switch after 4 years, after 5 years, because of usage. Right? We're using this limit switch so much based off of calculations that we may have a high chance of experiencing a dangerous failure with this device. Okay. Safety components are designed to fail to safe. This standard, the ISO 13849, looks at the probability of a dangerous failure, which is unique. Right? It's saying that there is going to be a chance. Right? Murphy's law, right? If it can go wrong, it'll go wrong, right? So there's a chance that we can have a dangerous failure. Let's take enough precaution, let's introduce enough procedures to make sure that we avoid those dangerous failures. So again, we put inside a PM schedule to replace a safety component. All right. As far as reevaluating, we want to look at this machine periodically and do an assessment. Okay. Now, there's going to be things that automatically trigger a risk assessment. The moment that we honestly, lift the machine off the floor, this triggers a risk assessment, right? Anytime we move a piece of equipment, whether it's across the plant floor or 2 feet over, right, across the aisle, whatever the case is, the moment that you move a machine, this triggers a risk assessment, right? The moment that we change a process, right? If we add a connecting part to this machine, right? We add a conveyor belt, conveyor line. Anytime we're doing any type of modification, right? Whether it's small or considered small or large, this triggers us to say we have to reevaluate this machine. All right. Now, depending on the modification, it may be a relatively quick reassessment, or of course, it can be rather, extensive risk assessment involving some additional risk reduction measures, additional control measures, calculations, validations, verifications. Okay, but these are the steps. All right, these are the 5 steps in order for us to look at the overall machine safety life cycle. Okay, again, just wanted to give a quick overview of this topic, right? Looking at the individual steps, seeing what are going to be required within each of the individual steps. Again, there's a lot of information out there, and I kind of want to tie all that together, right, and give you some additional information on these 5 steps for the machine safety life cycle. Okay. I think there are some questions in the chat already, which is great. Let me go ahead and wrap up the other portions of the webinar here, and then I should have time for some questions, right? So this whole concept, right, looking at the safety machine life cycle and focusing on the safety aspect of it kind of leads us into what we're doing today here, right? This last Friday of June, which again is designated on the national calendar as National Safer Workplace Day. All right. And if we think about the concepts here of National Safer Workplace Day, SAFER is an acronym for stop, assess, formulate, execute, and review. All right. This was again created, by Schmersal this day because we wanted to highlight the importance of safety, right? With not just with machinery, but again within the industrial environment. And when we look at what we're trying to implement here, right, what we're trying to promote here, it's let's just stop. Okay, we see something dangerous, we see something that's not right. Let's stop. And again, this can be machine related or just anything within the industrial environment. We see something that's not safe. Let's pause. All right, let's stop, and then let's assess the situation. Okay, let's find out what's going on. Is this something that we need to address, whether it's with policy, process? Is this something that we need to address with a control measure, like with the risk assessment, like we just went over, right? So let's assess the situation, and part of that assessment can definitely be going through a hazard rated number, an HRN, right? Or if we look at ANSI B11.0, right, some type of a matrix to say, okay, based on what we've assessed here, we may need to add some type of risk reduction measure. And then that will lead into formulate. Okay, fine. We need to address an issue here. Let's formulate a plan, right? And again, this does not have to be tied directly to machine safety. All right. So if there's an issue, let's figure out what that issue is, and then let's formulate a plan of attack. Okay. This is going to be a team effort, of course, right? We have to find out, what the situation is, why the situation even arised, and let's formulate a plan. Okay. For machinery, it's, maybe we had a near miss. Okay. We had a near miss. We do an assessment, and we figure out, let's formulate a plan. Let's add some additional guarding, right? Whether it's hard guard or some type of safety component within the industry. Then it's execute. Right, let's go ahead and put this plan in action. Right. Again, if we go back to what we just went over, let's go ahead and look at our safety function requirement specification. Let's do the design, right? Validation. Let's implement it. And then the last part of review is, well, let's look at what we have in place. Is this acceptable? Do we need to do anything else further? All right. Um, Sometimes that first solution isn't the best. Sometimes we can tweak it a little bit, but the part is review, right? Just like again, the 5 stages. It just so happens to be, honestly, that safer, 5 letters, right? But it's that process that's constantly repeated. I mentioned at the beginning of this webinar, this idea of the machine safety lifecycle is drawn from various different functional safety standards, or not even functional safety, from other standards as well. This concept of the machine safety lifecycle, or a safety lifecycle, I should say. And in most cases, it drills down to 5 steps. And as we see with this acronym for National Safer Workplace Day, again, it drills down to 5 steps. Okay. So we created this day to highlight the importance of safety within the industrial environment. Some quick. I think we have 3 quick data information that we show here, where it's 83%. Okay, 83% of active workers in the U.S. have seen some sort of workplace emergency while working. That's an amazing number. Okay, and doesn't go into what that emergency is and how serious it is, but it's an emergency. Okay, 83% of active workers in the United States have seen some sort of workplace emergency. Okay, and that's always, whether it's small or catastrophic, it can be life changing, right? For the person obviously that experienced it, or the person that has witnessed it. Okay, we always want to make sure that we go home the same way we go into work, right? This stat was provided by Forbes. The next stat would be 50%. Okay, 50%. A workplace safety program reduces injury by 50%. That is a high number, and all you're doing is implementing a safety program. Okay, and I say all you're doing, yes, it does involve some work for sure, from the top down, right? And it needs acceptance, right, buy-in. But if we have a plan in place, a program, we can see this huge number of 50%, right, of injuries being reduced. Again, this could be a light injury or something catastrophic, whatever it is. It can be. We can save someone's life. We can save someone from a life-altering situation. Okay, this stat brought to us by the American Society of Safety Engineers. right? The last stat would be 43%. All right, and what are we looking at with this stat of 43%? 43% of workers believe that the employee could be doing something more to reduce safety incidences. Okay, 40% of workers believe that their employee could be doing something more. When we look here in the States, when we look at the OSHA, the requirement is for the employer to provide a safe working environment. Okay, and again, to me, this is a high number. All right, this is people that are going to work and essentially not feeling that safe, or feeling like their employee can do something better. All right, now, again, this day, right, this National Safe Workplace Day, this is what we like to do is a times a day to highlight this so that we can focus on the safety aspects of, in this case, right, the industrial environment. So you know what, I'm going to work today in the factory, and I'm one of the 43%, right, that feel like my employer can do something different. You know what, let me go to my safety lead, right, and let them be aware, you know what, this is National Safer Workplace Day, right? Let's recognize this. Let's do something about this today. Okay. Remember, safety is your responsibility. Okay. Safety is not everyone's responsibility. Right? It's your responsibility. Right? Because when we say safety is everyone's responsibility, then it over time it becomes no one's responsibility. Right. So if you hold yourself accountable for safety, and everyone else holds themselves accountable for safety, we will see a change in culture for safety. These numbers that we show, at these three stats that we show, and the stats that unfortunately we can always show, right, for injuries and workers not feeling safe. And there's a whole slew of stats that you can look through, right? Which is why we again wanted to focus on this day as part of National Safety Month. Okay, so this is the one of the reasons right behind National Safer Workplace Day. In the handouts, in your dashboard, there is a flyer for it. We have a whole website dedicated to this initiative. Again, we're proud to be one of the only safety manufacturer, right, and safety solution division, Technicum, to be able to have such an initiative. And as you see, we are not focused on what we can do for you and the product side of it. We really want to just take this day to highlight the importance of safety. Okay, now what can you do? Right, what can you do to help promote this initiative? Help get the word out to help make sure that again that we can continue to have employees go home safely, right? Especially here in the summertime, right? It's the time to spend with the family. Kids are out of school. You want to make sure that we stay safe throughout the year, of course, right? But here we are again with National Safety Month. Okay, so what can you do today, last Friday of June? You can acknowledge a coworker or employee for following safe practices. Why? All too often we see someone get reprimanded for not doing something right. Okay. And depending on what they're doing, right? They're doing something like blatantly unsafe, then yes, all right, they should be reprimanded. We need to find out why they did what they did so they don't do it again. Okay, for sure. But a lot of times, people that are doing their job safely and following the safe protocols and help fostering that safe culture, we need to make sure that they are acknowledged as well. Okay. So what you can do today, acknowledge the coworkers. All right. If you in the management, acknowledge the employee for following a safe work practice. It can be something small, can be something big. All right. What else can we do? Identify a task or process and find a way to make it safer. All right. Again, looking at that stat where 47, 43% of workers felt like the employee could be doing something better. right? So here's the chance, let's look at this task, let's look at this process, and let's find ways together to make this safer. Okay, can it all be implemented? Maybe not, right? Can it be implemented today? Probably not, but let's get a plan together, right? Let's make people aware so that we can make it safer. Okay. The last thing that we can do to recognize National Safer Workplace Day is share your safety initiative. Right. Go online. Right. Share what you've done with safety. All right, or keep it in house, right? Talk to your coworkers, right? What have you seen some of the progresses with safety? What have you tried to implement some safety programs, right? If you are going to go online and share your safety initiative, be sure to tag us, Schmersal and Technicum, and we can go ahead and share your story if you want with our audience, right? The key thing is being able to promote safety, right? This is the month for it. This is the day for it. Every day throughout the course of the year, we want to be safe. This month, this day is designated to highlight that, right? So let's take advantage of it. National Safer Workplace Day. Okay. Now, um, because you have attended this webinar, which I do thank you for, you are automatically entered into a drawing for a grand prize. Right? If you choose to receive it, if you win, okay. The first option for the prize is to receive for your organization a free training. Okay, the training that we are offering is our general machine guarding training. Right? This is a one-day training, maximum of 35 attendees. It can be either online or in person, so we can go to your site to do the training. Our training program that we have created is approved by, or we are an ISET provider, or ISET approved provider, excuse me, where we can offer continuous educational units. Okay, the estimated value for this prize is $8,000. The other prize that you can select would be a machine safety walkthrough. So if you would like, we can have one of our safety engineers come to the site to do a walkthrough, whether it's for one machine, a handful of machines, to do a plant tour with you to help highlight some issues that may be addressed. Okay. Or if you have machines that keep you up at night that you want us to look at with you, by all means, again, we can take the opportunity to do so as well. A full day on site, looking at an estimated value of $5,000 for that prize, right? So these are free. Just for attending this webinar, you've been entered into the drawing. We will definitely reach out and we will make it known on our social media who has won this prize. Okay. With that, ladies and gentlemen, I thank you for starting this Friday off with me this morning, starting off National Safer Workplace Day with us. Please feel free to reach out to us if you have any questions, comments, or concerns. Um, promote promote the day, right? Feel free to go to our social media platforms, share what we have. We'll be happy to share what you have. Let's let's stay safe, everybody. Again, thank you so much. Enjoy the day, enjoy the weekend, and stay safe.